the explanation for compound interest. And this is the formula that we use in compound interest. So now this is the explanation for annuity. And this is the formula that we use in annuity.
Let's start doing tutorial question. So, how much will his 5,000 ringgit become when he is 31 years old? We can use the future value formula in compound interest to calculate the total amount he will save later. But before that, we need to identify the information given in the question. We are given K, nominal interest rate, equals to 5%. We need to change it to the decimal number that is 0.05. And the frequency is how many times it will be compounded equal to 1. T, time, how many years did he save equal to 10 years. And the capital P, principal, is the amount of money that he deposited equals to 5,000 ringgit. Let's start solving it step by step. First, we need to calculate the periodic interest rate, I. Formula for I is I equal to K divided by M. Insert the value of K and M that we put aside before. Next, calculate the total number of interest period N. We know that the formula for N is N equal to M multiplied with T. So it will be N equals to 1 multiplied with 10, and the value of N is 10. For the final step, we need to use the future value formula. That is capital S equal to capital P, open bracket, 1 plus I, close bracket, in the power of N. Then, you can just total it up by using your calculator. So, that 5,000 ringgit will be 8,144 ringgit and 47 cents when he is 31 years old.
Problem. Compare costs of two plans. A. Save one lump sum today. B. Save monthly until baby is 18 years old. First, we use this formula. A equals to S over 1 plus I the power of N. S is 150,000 and 18 times 12 equal to 216. I equal to 0.06 over 12. Next, A equal to 150,000 over 1 plus 0.06 over 12 the power of 216. The answer is A equal to 5,176.60 cents. B. Save monthly until baby 18 years old. We use the formula A equal to R, 1 plus I the power of N over I. 150,000 equal to R, 1 plus 0.06 over 12, the power of 216 minus 1 over 0.06 over 12. After calculate, we got R equal to 387 ringgit 24 cents. The total deposit is 387 ringgit 24 cents times 216 equal to 83,643 ringgit 84 cents. Let's compare it with these two plans. Plan A is 51,076 ringgit 59 cents. Plan B is 83,643 ringgit 84 cents. Which one is cheaper to achieve 150,000 ringgit? The answer is Plan A is cheaper to achieve 150,000 ringgit. That's all.
33. Because the question is how much money will he have in ASB at age 33. So for the first step, we must understand the timeline. First, at age 23, he must deposit 12,000 ringgit. Second, ASB gives 5% interest per year compounded annually. Third, after 4 years, when he turns 27, he adds 8,000 ringgit more. Fourth, from age 27 to age 33, there are 6 more years of growth. And last, we calculate the growth of 2 stages. For the step 2, we must calculate the growth of the first 12,000 ringgit for 4 years. For this calculation, we must use the compound interest formula, which is S equals to P 1 plus I N, where P is 12,000, I is 0.05 over 1, N is 4. So we must put all the numbers into the formula, and we will get 14,586.08 ringgit after 4 years. For the step 3, we must add the second deposit, which is 8,000 ringgit at age 27. So the new total of the amount we now invest for the next 6 years is 22,586.08 ringgit. This is the P2. So now, we need to calculate that total for another 6 years. Again, we apply the compound interest formula, which is S equals to P 1 plus I N, where P is the new number that we calculate just now, which is 22,586.05. I is still the same, which is 0.05 over 1, and N is the new, N is 6 because that is for another 6 years. So after we put all the number into the formula again, we will get the final amount at age 33, which is 30,267.51 ringgit. By age, so the final answer is, by age 33, the engineer will have 30,267.51.
We move to question number 4. You have a BTBT and loan balance of 20,000 ringgit. The interest rate is 6% per year, compounded monthly. The original repayment plan is 7 years with a monthly installment of 292.17 cents. To find the original loan term, you multiply 7 years by 12 months. 7 times 12 equals 84. So the loan term is 84 months. Then we need to calculate the total payment. RM 292 ringgit 17 cents times 84 equals to 24,542.28 cents. To find the interest paid, take the 24,542.28, which is the total payment, minus 20,000 ringgit equals 4,542.28 cents. So the total interest paid is 4,000. 1,542.20. Now, if you increase your monthly payment by 150 ringgit, the new payment becomes 292.17 plus 150 equals 442.17. We want to calculate how many months it will take to finish the loan with this new payment. Now, I'll do it step by step using the Annuity formula. The formula is A equals R, open bracket, 1 minus, open bracket, 1 plus I, close bracket, to the power of negative n, close bracket, divided by I, close bracket. So now, we just follow the formula, where we know A is the loan's amount, R is the monthly payment, I is the monthly interest rate, while N is the number of months that we want to find. Next, we need to substitute the values. As we know, A is a 20,000 ringgit, so 20,000 ringgit equals 442 ringgit point 17 cents, open bracket, 1 minus, open bracket, 1 plus 0.006 divided by 12, close bracket, to the power of negative n, close bracket, divided by 0.006, divided by 12, close bracket. Now, divide both sides by 442 ringgit point 17 cents equals to 20,000 ringgit divided by 442.17 equals to what? The answer was in the next page. After dividing both sides, we will get 45.23147,206 times 0.06 divided by 12 equals 1 minus, open bracket, 1.005, close bracket, to the power of negative n. Now, rearrange. Open bracket, 1.005, close bracket, to the power of negative n equals 1 minus 0.2261573,603. Next, negative n times log 1.005 equals to log 0.773842,63997. So, negative n equals to negative 51.4054. N equals to 51.41 months, which is about 51 months. Therefore, N equals 51.41 months, which is about 51 months, divided by 12. We will get the new long term equals to 4.25 years. Next, to calculate the year shortened, take the 7 years minus 4.25. You will get 2.70. Now, this is the final calculation. To calculate the total repayment, take 51 times 442.17 cents equals to 22,550.67 cents. Now, we'll count the new interest paid. The formula was I is the interest saved equals to R is the installment or payment per period, N is the number of remaining periods, A is the outstanding loan amount or balance. So, the formula was interest saved equals R times N minus A. Now, calculate the interest saved, which is 4,542.28 cents minus 2,550.67. We will get 1,991.61 cents.
Congrats, you managed to survive until question 5. So, how much money will she have at age 41? How can we know that the amount of 2,400 ringgit is R? We can see the word per year consistently in the question. That means the amount is repetitive. The repetitive amount will be used as a periodic payment, R. Step 1. You can start calculating the value of the periodic interest rate and the number of interest periods just like we did in question 1. By then, we will get the value of I is 0.0515 and the value of N is 10. She starts investing with 10,000 ringgit. Since she keeps it in the account until age 41, this lump sum grows for the entire 15 years. We need to use the compound interest formula again to know how much that 10,000 ringgit will grow after 15 years. Next, use the same formula as we did in question 1. Capital S equal to capital P, open bracket 1 plus I, close bracket, in the power of N. Insert all the values that we have into the formula. Then total it up. So that 10,000 ringgit will be 21,339 ringgit and 25 cents after 5 years. She also contributes 2,400 ringgit per year for the first 8 years. This regular saving is called an annuity. Next, we need to calculate the total value of her annual contribution for 8 years. Use the future value of an annuity formulas. Insert all the value and total it up using your calculator. The total outcomes will be 23,041 ringgit and 18 cents. Then, she stops adding money, but leaves this entire amount to grow for the remaining 7 years. We treat this 23,041 ringgit and 18 cents as a new principal. Now, we want to calculate the remaining 7 years by using the compound interest formula just like before. After that final 7 years of growth, her contribution segments become 32,746 ringgit and 86 cents. To get the final answer for how much she will have at age 41, we need to add the two final values together. Let's do it together. 21,239 ringgit and 25 cents plus 32,746 ringgit and 86 cents. By then, she will have 53,986 ringgit and 11 cents at age 41. That is the end of our tutorial question. Thank you for watching.